So in this video here, we're going to be warming up with some basic algebra skills, and specifically skills on how we divide with exponents and how we factor. So starting with the dividing part, if I'm trying to divide x cubed y over x squared, the first thing I'm going to notice is the top and bottom both have x's. So that means I can try to cancel some out. Notice how the bottom has an x squared. That means I can take away x squared because the top is x cubed. And so if I take 2 x's away from the bottom, I have to take 2 away from the top. So that would leave me x to the first power. So all I have left is x to the first power times y. So my final answer would just be x times y, or xy. And I can't really simplify any further than that, so this is my final answer. But let me just do that problem in slow-mo. So one of the basic concepts that you learn in algebra is that whenever you have two variables that have the same base, and they have, let's say this top has an exponent of a and the bottom has an exponent of b, when you divide, you always subtract the top exponent from the bottom. So what happened here is that essentially, if I were to redo this problem in slower pace, this 3 minus 2, if I wrote that out, 3 minus 2, and then bring down the y is just to the first power. There's no y in the bottom. And so 3 minus 2 is just x to the first power. And you can see that's how I got y x times y. So if you need to show that work, definitely do that, because that definitely will help you understand how to subtract those exponents when you're canceling out or when you're dividing. So let's practice that skill here. So this one's a different scenario. Notice that the top has a plus sign. So anytime I notice a plus sign or a minus sign, generally what I'll do is split the numerator up with the denominator. One of the biggest mistakes students will do is they'll cancel this with the first x, but they won't do it to the other one. And so a good practice is anytime you see two terms in the top is just to split it up with the bottom. So this x gets divided by x, but also the second term, xy, also gets divided by x. And so you'll treat these two as separate fractions. And so x divided by x is just 1. These two x's, there's a x on the top, x on the bottom, so we can cancel those out, leaving us with just the y that is to the side. So I have 1 plus y, and there's really not much I can do to join them together any further, so this is the furthest I can simplify. Now this next one here, very similar to the one we just did. Again, I noticed that there's a minus sign, so maybe the first thing I want to try out is to see if I can split them into two fractions. And from here, what I can do is take a look in the top and the bottom and see what they have similar. I notice that both sides have an x, and so I can cancel out this x, which is x to the first power, so I have to take away one x on the top, so that leaves me x to the first power on top. So that means here I have x on the top, and I have just a y left on the bottom since this x got canceled. So that's all I have left on the top. This one here, it looks like it has a y in the bottom and a y on the top, so I can cancel out that y in the bottom and cancel out one of the y's on the top, which would leave me with y over x. And from here, these do not have common denominators, so I can't subtract them. I could try to find a common denominator, but I'm not going to in this case. I just really want us to practice being able to learn how to divide, not necessarily subtracting fractions. We'll do that in further problems. So in our next warm-up problem here, we're going to be focusing on factoring. When it comes to factoring, what you're trying to figure out is what are all the factors that multiply to give you that expression. So sometimes we use parentheses, sometimes we're trying to pull out as many common, what we call common factors. So in this case here, we're trying to pull out the greatest common factor. And what I notice about these two terms is they both have x's. So I'm trying to figure out what do both of these terms have in common. And they both have an x, and they both have at least an x squared. This is x to the fourth power. So what I can do is bring out or divide out an x squared. So if I take out an x squared, that means that this right here is left with a y. Bring down the minus sign. And then this has to be an x squared in order to be x to the fourth power. Notice if I were to redistribute, x squared times y gives me that first term, and x squared times x squared gives me x to the fourth power. And so this works. And then from here, I really can't simplify or break this down any further, since this here is not like a square. So I can't factor this any further. So I'll leave my answer like this. In our next problem here, we have a trinomial, and this is a common problem you see in Algebra 2, and there's many ways you can factor, but I'll teach you my way of how we typically factor, and there are, like I said, many ways, but the way that I've learned it is if you notice that this has an x squared, we're going to write down our x's because we're going to need two x's to make an x squared when we multiply or when we FOIL it out. Now, the trick is to figure out what two numbers multiply to give you the constant. So if this is like your A, your B, and your C, the C is the constant. So thinking about two numbers that multiply to give you 10, well, let's try 5 and 2. There's 10 and 1, and I think that's it. And then what we have to realize is that C is two numbers that multiply to give you that number. So that's why I was thinking about the factors. But the B, or the term in the middle, is two numbers that add to give you that term. So once you figure out what two factors work, I think in this case 5 and 2 are going to be the ones that work here, because what I notice is that the middle term is 3. And the only way to get 3 is if I have 5 and 2. So I'm going to put those down first. And so I noticed that in order to get the negative 10, I have to have two numbers that multiply to give me negative 10. Well, 5 and 2 multiply to give me 10, but in order to get a negative number, one of these has to be a negative and one of them has to be a positive. So to choose, I use the middle term to help me out. The middle term is a positive 3. In order to get a positive 3, the 5 had to have been a plus sign and the 2 needed to be a negative sign. The reason why is because positive 5 minus 2 gives me a positive 3, so this works. And so I have now found my factors. Basically, the key to factoring trinomials is to figure out what two numbers multiply to give you the constant, and then out of the factors, figure out what two numbers add to give you the middle term. Also, a little trick here is if you notice this sign is negative, use the middle term. If this is positive, that means the bigger number needs to be positive. If this was negative, the bigger number needs to be negative. So that's also one of my tricks. But I have factored this, so I'm going to move on to the next problem. So using the same idea again, I'm going to start out with my constant, or actually I can write out my parentheses first and put down my x's. So thinking about two numbers that multiply to give me 1, well, I don't have a lot of options. It's just 1 and 1. And so what I notice is that this term is positive and so is the middle term. So that tells me that probably all of them were positive to begin with. And so 1 times 1 gives me positive 1 and 1 plus 1 gives me positive 2. So this works. By the way, if you don't trust me or you're kind of weary about, making sure your answer is correct, that your factors are correct, all you have to do is go ahead and FOIL it out to double check. So if you need to check your answer, you can always use the FOILing method where you multiply things out. So if I multiply this out, I would get x squared minus 2x, and then multiply the 5x, which gives me 5x minus 10. And so notice that the middle terms end up giving you that positive 3x minus 10. So if you need to show that extra work just to make sure that your factors do give you that trinomial in the beginning, definitely do that. I think that's a great way to practice. But these were my two factors that I found. All right, so now that we're warmed up here, let's get into our fundamental identities. So you're going to be learning quite a few identities and we're going to be using them quite a bit. So they are kind of like our vocabulary here. And some of these are not new to you guys. Actually, probably 60% of the identities that you see here are ones that you've already seen. Like for instance, cosecant, we've learned is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. And these are what we call the reciprocal identities. It's just basically telling you another way you can represent cosecant, secant, and cotangent. You can also represent sine, cosine, and tangent as reciprocals of the cosecant, secant, and cotangent. So what I mean here is sine would be 1 over cosecant, and cosine would be 1 over secant, and tangent is 1 over cotangent. So that's how we can represent something that is reciprocal. Remember, things that we put in the denominator causes a fraction to flip, and so that's why this is an easy way to represent reciprocals, is to put them in the denominator. All right, another thing we want to mention is the quotient identity. Now, you guys are probably familiar at this point with tangent quotient identity being sine over cosine. So oftentimes we want to express trig functions as sine and cosine. For cotangent, it's just the reciprocal of tangent. So this one is cosine over sine. And then these are going to be the new ones that we haven't learned yet, and we're going to practice quite a bit using Pythagorean identity. So the Pythagorean identity says that if we take sine squared and we add it with cosine squared, turns out you get 1, which is kind of cool. It's like you went from trig functions to a real number. And then this one says tangent squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared. Now, one of the things I want to mention is this exponent here. So notice how the tangent or all the trigs might have a square or an exponent. So one of the things I want to clarify is anytime you notice this, like something that's being squared as a trig, you'll notice the exponent is between the sine word and the angle. This is the same as saying sine theta is being squared. Okay, these two mean the same thing. And I want to mention this because this is usually the first time you will notice that sine now has an exponent. And when we write exponents for trig functions, we generally write it between the word and the angle. So it's kind of weird, but that's how we write things. All right, so let's get into our first example here where we are utilizing the trig identities. So what we're going to do here in the first example is we're going to be given a trig expression, as you can see here, and we have to write all the ways you can express the same trig values. So what we're doing is we're kind of pulling from those fundamental identities from the first page and rewriting the trig expression that we're given. So in this case, tangent. Tangent can be written as, that we have seen, we can write it as sine over cosine using the quotient identity, which is right here. So tangent can be expressed as this as well. Tangent can also be expressed as its reciprocal identity, which is 1 over cotangent. So I will write that down. 1 over cotangent is another way we can express tangent. And then let's see if we can find anything else. So these are for cotangents. There's not a tangent in here. This one's tangent squared, so I can't use that. So I think that's it for now. Now for this one here, we can see that this is cotangent. And, one way we can express cotangent is the reciprocal, which is cosine over sine. We can also say it is 1 over tangent. And I think that is it. I don't see another cotangent. So that was the one that I used, and as well as that one. All right, let's see what our next one is. So this one is secant squared. All right, so when I'm thinking about secant squared, I notice the first thing that I notice is that secant squared is tangent squared plus 1. So I can use all of that to represent secant squared. So I'm going to go ahead and write that in. So tangent squared plus 1. Let's think of other things. So secant is a representation of cosine, right? So here's secant, and secant's 1 over cosine. Well, if I just square secant here, right, I'm going to have to square all of this. So if I were to do that, I would get 1 squared, which is just 1, and I would get cosine squared in the bottom. So I have to square the top and bottom. So essentially what that would end up looking like is 1 on top and cosine squared on bottom if I'm representing secant squared. And I think that's all the ways I can represent secants, because that's the only one I see, and that one, which I'll go ahead and erase that now. There we go. Now, some of you are probably wondering, why are we trying to rewrite these trig expression in a different way? Well, that has to do with learning how to develop the skill of substitution. Now, in these next few problems, we're going to be manipulating quite a bit, and we need those fundamental identities on the first page to be able to manipulate. And so we're building the skills of recognizing what the trig function is and different ways we can express it, because there's going to be a situation where it's not easy to simplify with what you're given. So we have to change the way it looks so we can simplify it further. And I'll explain more in the next video. So until next time, guys, bye.